We're going to take a look at practice question set number 28 on Millikan oil drop experiments. This first question says a group of students performs a Millikan type experiment with 3 charged plastic beads. This is why it says Millikan type, right? Because the actual Millikan oil drop experiment used oil drops. They're using plastic beads, which is pretty much like the oil drop experiment, except it's a lot easier to deal with than it is with the oil drops. Anyways, we put these plastic beads between oppositely charged parallel plates. The plates are placed 4 centimeters apart, and each bead has a mass of 1.87 times 10 to the negative 14 kilograms. 10 to the negative 14 kilograms, as compared to, say, the mass of an electron that's 10 to the minus 31 kilograms. Remember, in the cathode ray tube, the velocity selection chamber, we said that we have gravity acting on these electrons, but we ignore it because it's so ridiculously small compared to the other forces that it's just not important. The reason it's so small in the velocity selection chamber is because you're dealing with the mass of an electron, which is 10 to the 17 times smaller than the charge of this plastic sphere. And although the mass of these plastic spheres is still really, really, really small, it's 10 to the 17 times bigger than the mass of an electron, which means that it's much more significant than it was in the cathode ray tube. That's why we got to pay attention to it in the oil drop experiment, right? That's why it's important, because although you're dealing with small masses, they're still a lot bigger than the mass of an electron. Three plastic beads in there. We get X, Y, and Z, and then it tells us that bead X remains suspended. Bead Y moves toward the top plate at a uniform, or what's another word for uniform speed? Constant speed of, doesn't matter what the speed is, constant speed is a constant speed. Or accelerates toward, and Z accelerates toward the top plate at 14.7 meters per second squared. We see some free body diagrams here, a bunch of them, and then we want to identify which free body diagram goes with each bead. That's the question, right? What I would suggest to do in a question like this is not be led by the diagrams that we have there. Sometimes we have to. Sometimes we have to look at the options and place them as we see fit. But we know how to draw free body diagrams for this, so we're going to do that. Like, we're going to draw them not looking at the diagrams below because we don't want to be influenced by some trick that they're throwing in there to try to mess us up. Okay? If we have to look at them, we look at them. But if we can do it without looking at them, then that's what we'd want to do here. Bead X remains suspended. Gravity acts which way when a charge is suspended? Alex? Down. Good. So we're going to make gravity down in this case. If it's suspended, the electric force is going to point which way? Upwards. And what do we know about the length of the electric force, or the magnitude of the electric force? It's exactly the same. If it's suspended, then the electric force has to be equal and opposite to the force of gravity. Now let's move on to the one that's moving at a constant speed. That's bead Z, or bead Y, I should say. Bead Y, gravity is still acting down, and because it's the same mass, it's going to be the same force. Which way is the electric force acting? Upwards. How big? Not bigger than Fg. It should be the same value as Fg. If it's moving at a constant speed, the net force is 0. And if the net force is 0, then the two forces have to balance. So for the first two, whether it's suspended or constant speed, it doesn't really matter. We say Fe equals Fg, right? That's how we analyzed it. For a charged particle suspended or moving at a constant speed, we said Fe equal to Fg. Now, when it was accelerating, that wasn't the case. It's accelerating, this one is accelerating upward at 14.7. We know gravity is going to act down. The electric force has to act up. Tell me when to stop. It's quite a bit bigger, right? It's quite a bit bigger. So let's look at our options here. X is going to be option 3. Option 3 and 4 look a lot alike, though, eh? Notice, though, option 4, Fe is a little bit bigger than Fg, which is going to cause it to accelerate upward, but not at a rate of 14 meters per second squared. Number 3 is the case for the second one as well, bead Y, and bead Z looks like 5. So we're going to say 3, 3, 5 is our answer for that one. And we want to find the electric field in the region between these oppositely charged plates. We know that E is equal to delta V over delta D. Going back to stuff from a couple months ago here now, electric field between plates is potential difference, the potential difference divided by the distance between the plates, or 1200 volts divided by 0.040 meters, which I think was 3,000, was it? Or 30,000. I think it's actually 30,000, 3 times 10 to the 4 volts per meter. Which way does it act? Field acts downward, right? From positive to negative. So we're going to say 3 times 10 to the 4 downward. Or 3 times 10 to the 4 toward the bottom plate. The nature on charge, or on bead X, the nature of the charge. The nature of the charge on X. On X, the electric force is up, the field is down. What type of particle must that be? Seth, what do you got to have if you have a force upward and a field downward? Positive or negative? Negative. Positive goes with the field, negative goes against the field. The force is against the field, it's got to be a negative particle. So we're going to say the answer to that one is, oh, they ask us more, I guess. It's negative because it's gained, right? Because it's gained. C or D. How many has it gained? Well, we'd say Fe equals, this is a nasty little trick they give us on this one, actually, on this question. A really nasty trick. Like, sometimes they give us really hard questions. Okay, that's fine. Sometimes we don't like those hard questions because they're hard to do, but at least we can respect those hard questions. It's hard to respect this one because it's just mean what they do to us on this one. You'll see what I mean in a second. Fe is equal to Fg, or QE is equal to M times G. Solve for Q. And when we solve for Q, I'm not sure what we get, but when we divide that by 1.6 times 10 to the minus 19 to get the number of electrons, I think we end up getting 38.2. Is that right? So the answer would be D, right? No, the answer is C. Okay, I don't care if you get 38.2. You cannot gain 38.2 electrons. Okay, I think that is so mean because it's not a matter of, this isn't a matter of like, do they know their stuff? This is a matter of, let's try to trick them by putting 38.2 when that's the number they got. Now you could argue that, well, if you're really, really thinking, you're not going to get tricked by it. But still, it seems like that's the attempt of that one. But they don't usually do stuff like that to us, but every once in a while. Anyway, the answer is 38. You will never, in any of these questions, answer anything other than a whole number. Got it? 38, 722, 2, but it's never going to be 38.2 or 722.9 or anything like that. You're going to always answer a whole number. Okay? And if it happens to be something other than a whole number, round it. Round it to the right number of digits, or round it to the whole number. Having said that, I think you're going to find that it's either going to be a whole number or really close to a whole number. I don't think you'd get 38.5. Yeah, I don't think they'd do that to you, even though technically that would round up. I think that was it, wasn't it? Nope, there's more. An oil droplet that has 2 electrons removed from its surface. What does that mean? Charges become what? Positive. It's near the Earth's surface containing an electric field. Here's the electric field. It's 2 times 10 to the 5 upwards. We've got an oil droplet that's positive. We've got a force of gravity that's down. Which way is the electric force? I'm positive the force is with the field, so it's going to be upward. Now, we don't know how big it's going to be. That's okay. We'll find out how big it's going to be later on. We're going to say F net is equal to the sum of the forces, Fe plus Fg. We're going to say Ma is equal to Q times E plus Mg. We sub in our numbers here. 3.8 times 10 to the minus 15. We're solving for A. 3.2 is my charge, 2 electrons. Electric field is 2 times 10 to the 5 plus mass 3.8 times 10 to the minus 15 times 9.81. Let's worry about signs now. Is the electric force positive or negative? Kelly, electric force positive or negative here? Yeah, you do. Good. So, Kelly, we are going to make that positive. You're right. Gravity is going to be which way? We're going to make that negative because it's downwards, right? When we do that, I can't remember what we ended up getting. I want to say it was A, was it? Yeah, 7.0 meters per second squared. And it worked out to be a positive value, which, again, we think about signs. We get a positive value, it just means up.